Hello, everybody. Today you see that I am in my phi house, my rhombic triicontohedron house. That's, of course, a topic for another video. You could look up Jamie York phi house on YouTube and find that out. But what I'm going to do today is present to you a particularly interesting puzzle. I call this the blind coin puzzle, and you'll see in a moment what exactly I'm talking about. I'm going to go ahead now and explain this. So what we're going to do is we're going to start out with a certain number of coins on a plate. And some of those coins will be heads and some of them will be tails. And all we need to do, it's quite simple. We're going to move some of the coins from one plate to the other. And we need to make sure that in the end, after we've moved the coins, that we have the same number of heads on both plates. Now, the other rule is, or the other possible thing that we can do is we're actually allowed to flip some of the coins. So if one coin is a head, we can flip it over and make it a tail. If it's a tail, we can make it a head. So let me give you an example about how this would work. Again, the end result, the goal is we want to have the same number of heads on both plates. We don't care about the number of tails really, just the same number of heads. So let me go ahead and show you a couple of examples of this. So here we are. It turns out that the number of coins are 18. We have 18 coins. We have 10 heads. I believe that you can see some of them. You can see this one pretty clearly is a head. It's the head of Thomas Jefferson. These are all USA nickels worth 5 cents. And then we also have some tails. You can make out here, this is actually a building that we have on the back side of the nickels. Turns out here with the 18 coins that 10 of them are heads if you count them. And I know it's hard to make some of them out on the video. That's all right. So trust me, 10 of them are heads and 8 of them are tails. So again, what is the goal? I'm going to flip some of the coins. And I'm going to move some of the coins from one plate over to the other. So one very simple solution would be to just take 5 heads. I'll do that. I just took 5 heads, moved them over there, and I could take a couple tails as well, move them over there. I just moved 5 heads and 2 tails over to here. And so therefore, what do we have? We have 5 heads in the left tray and 5 heads in the right, and therefore that's a solution. I didn't flip any of the coins in that case, but I could do that now. Another possible solution would be to flip, I don't know, I could flip 2 of the heads here, and now all of a sudden I have 8 heads, and then I could go and move 4 of the heads from here to here, and I could move a couple of the tails. I could flip them either before or after I move them, but again, the goal is when I'm done, I need to make sure that I have an equal number of heads in both trays. So in this case, I ended up with 4 heads in both places. Of course, there are many, many different solutions, many different ways to do this. So as you can see, so far, it's not that big of a challenge, is it? You can actually move however many coins you want. You can flip however many, and it's quite easy to actually produce a situation where you have an equal number of heads in both trays. I could have flipped all of the heads if I wanted to. Could have flipped all the heads to be tails so there are no heads whatsoever. And then I could move some of the tails or not into the other tray. And the reality is there would be 0 heads in both tray. That would be a legitimate solution as well. So what makes this hard? What makes this challenging? Well, here's the huge challenge. I called this the blind coin puzzle because you must do this completely blindfolded. You're not allowed to see which coins are heads or tails. In fact, you can't see it all. You can feel the coins in the plate, and you can feel how many coins there are, or let's just make it a little bit more reasonable. Well, imagine to do this that you have a friend who actually tells you at the beginning the total number of coins that are in the tray, and your friend also tells you how many heads there are and how many tails there are. So again, at the beginning here, your friend would say, oh, there are 18 coins. Happens to be that 10 of them are heads and 8 of them are tails. And then your job is to flip some of the coins and move some of the coins. so that in the end, you're going to have an equal number of heads in both of the plates. Now, there's no trick to this. So you can't feel the coins and tell by feeling which ones are heads and tails. We'll assume that that's not really possible. But all you can do, you're just told that information at the beginning, and that's all that you're told. You're told the total number of coins, how many are heads, how many are tails, and then the rest of it you must do completely blindfolded by flipping some of the coins and moving some of the coins. And in the end, you must guarantee that what you've done, you'll have an equal number of heads on both of the plates. So that's the puzzle. You have to figure out a strategy where you could actually do that. So if you do have the proper strategy, then you should be able to, for instance, you should be able to act this out, actually have a blindfold on your face, and somebody could actually lead you through it by telling you, because they can see the coins, how many coins there are, how many heads and tails. And then even though you're blindfolded, you would be able to come up with a solution such that the number of heads would be equal in both plates. So that's the puzzle. Go ahead and have fun thinking about that. I know I enjoyed doing this one as well.